Today, we will discuss all about relations and functions. Relation, it is a rule that relates values from a set of values called the domain to a second set of values called the range. A relation is a set of ordered pairs x and y. Next, function. Function is a relation which each element in the domain is related to only one value in the range by some rule. Using functional notation, we can write it in this way, which is read as f of x is equal to y. Is a set of ordered pairs x, y, such that no two ordered pairs have the same x value but different y values. Let us tackle on how to write a function rule. We have here our first example, number of CDs and its cost in pesos. 2 CDs that is worth 24 pesos, 4 48 pesos, 6 72 pesos, 8 96 pesos, 10 120 pesos. We will let the number of CDs as x and cost in pesos as f of x. Now, how much is the cost of each CD? The answer is correct, 12 pesos. Now, cost is equal to 12 pesos times the number of CDs. So if you're to write this in a functional notation, this will become cost, that is f of x, 12 pesos. We have here 12 and the number of CDs that represents as x. So our final functional notation is f of x is equal to 12x. We have here the second example, a table of values x, that is -2, 0, 2, -3, -1, 1, 3. Y values, we have 2, 0, 2, 3, 1, 1, 3. So here x and y, that is equal to f of x. Our x is the independent variable and f of x is the dependent variable. Now, what have you observed with the values of y? Okay, so it is the absolute value of 1. This will become f of x is equal to the absolute value of x. Third example, Maya has an internet service that currently has a monthly access fee of 199 pesos and a connection fee of 10 pesos per hour. Represent her monthly cost as a function of connection time. So we have here the given access fee of 199 pesos and the connection fee of 10 pesos per hour. So we will let x as the number of hours Maya spends on the internet in 1 month, and y as Maya's monthly cost. Now, the monthly cost or the total cost that is equal to flat fee plus hourly fee times the number of hours. So if you were to write this in a functional notation, the total cost represents y, which is equal to f of x, and f of x is equal to flat fee, that is 199, plus hourly fee, which is 10, and number of hours, which is x. So that is f of x is equal to 199 plus 10x. Let's try. Write the function rule of the following. We have two tables of values below. I will give you 1 minute to answer. Now, what is the function rule of the first table of values? The answer is f of x is equal to x plus 3. And second table of values, the answer is f of x is equal to 2x plus 5. A relation may be presented by using the following: ordered pairs, table of values, mapping diagrams, and graphs. Below are the examples of set of ordered pairs. These are the examples of table of values. The following are examples of mapping diagrams. These are the examples of graphs. This time, let us determine if the given set of ordered pairs, table of values, mapping diagrams, and graphs are functions or just a mere relation. I want you to familiarize the following correspondence: one-to-one correspondence, many-to-one correspondence, one-to-many correspondence, and many-to-many correspondence. As a review, let us keep in our minds that it is considered as a function if no two ordered pairs have the same x value but different y values. Take a look at the ordered pairs of the set F. Set F contains the ordered pairs 1, 3, 412072. Observe that the x values are 1, 4, 2, 7. So there is no the same x value. In that case, set F is a function. Next, set G contains the ordered pairs 3, 2, 4, 4, 3, 3, 8, 9. There is a repetition of the x values, which is 3, and it has different y values, which are 2 and 3. So in that case, set G is just a mere relation. Set H contains the ordered pairs 1, 2, 2, 3, 3, 4, and 4, 5. So our x values are 1, 2, 3, and 4. No repetition. So set H is a function. Let's determine if the following table of values are functions or not. The first table of values, we have there x is negative 3, negative 2, negative 1, 0, 1, 3, 4. And the y values are 10, 5, 2, 1, 2, 5, 6. So, by looking at the x values, there is no the same number. Negative 3 is different from 3. So, the first table of values is a function. Next, the second table of values, we have there the x values, which are 1, 2, 3, 4, and 5. Again, no repetition. That is a function. Last, we have there x values negative 2, negative 1, 0, 1, and 2. No repetition. That is a function. Let us determine if the following mapping diagrams are functions or just a mere relation. On the first mapping diagram, inputs are 10, 20, 30, and 40. Output of 10 is 15, output of 20 is 45, output of 30 is 25, and output of 40 is 35. No repetition in the inputs, which means the first mapping diagram is a function. Next mapping diagram, we have inputs A, B, C, and D. Output of A is X, output of B is Y, output of C, Y also, and the output of D is Z. No repetition on the inputs, which means the second mapping diagram is also a function. Last mapping diagram, inputs we have 2, 4, and 3. Outputs of 2 are 20 and 40. Output of 4 is 40. Output of 3 is 30. Observe that input 2 has 2 outputs, which are 20 and 40. There is a repetition in the input, which means that the third mapping diagram is just a mere relation. Last is to test the graph if it is a function or just a mere relation. By using a vertical line test, we can determine if the graphs are functions or just a mere relation. We will draw a vertical line on the graph. If it intersects at 2 or more points, it means that the graph is just a mere relation. If it intersects at only 1 point, it means that the graph is a function. The first graph, it intersects at 2 points, which means it is just a mere relation. On the second graph, we will draw another vertical line test. It intersects at only 1 point. That means the second graph is a function. Third graph, We have also a vertical line test and it intersects at only one point. That means the third graph is a function. Let's try. You determine if the following set of ordered pairs, mapping diagram, graph, table of values, are functions or not. I will give you 1 minute to answer. Answer number 1 is not. Number 2 is a function. 3 is not. 4 is a function.